Hi guys, this is lesson 6.5 and we are going to be applying systems of linear equations. In other words, we are going to do two things. Determining the best method to solve a system, we've already talked about that a little bit, and applying systems of equations, which basically means word problems. So let's have a look at some of the strategies here. So we have in this chapter seen that we can solve systems by graphing, by substitution, by elimination, where we just add, by elimination. Actually, we usually just make it adding. We haven't been using subtraction. I find that confusing, but you can. And elimination, where we use multiplication, and we did that in the last lesson. When we look at an equation like something like 4x minus 4y equals 8 and negative 8x plus y equals 19. Every method will work, but not all of the methods are equally direct or simple to use. In this case, the book is going to choose to use substitution because we can rearrange this equation pretty quickly by adding 8x to both sides and get y equals 8x plus 19. Then we can use this little expression, which is what y is, to plug into the other equation, 4y. So we can set it up by saying 4x minus 4 times 8x plus 19 equals 8. And then we're on our way. We need to use quite a bit of algebra, but we're on our way to solving for x. Once we've solved for x, we can plug it in for y, and we will have the answer. If we could see it on a graphing calculator, that would be a quick way to see the point where the two lines intersect. But we don't always have a graphing calculator handy, and graphing by hand can be kind of messy. Down here in the guided practice, you can see some quick examples of what you might choose to use to solve things. So in this one, because we already have 7x and 7x, if I just multiplied maybe the second equation by a negative, I could use elimination pretty quickly to make the y's cancel there. If you look at number 18 over here, or whatever that is, 1b, we can see that it might be super easy to times that one by 2 and get something where my y's would cancel. So we will use elimination. In number 1c here, we've already got set up to cancel. All we have to do is add it. We'll get 8x equals 16, and we can keep going. So elimination makes sense there. And then it's debatable. You can definitely use substitution for number 1d. You'd need to rearrange the equation to get y equals. And if you don't like doing the algebra to rearrange, you might like multiplying the top equation times 2, because then you would get that, and then you could cancel, and we can move on from there. So it's really a matter of personal preference and what you particularly can grab onto the easiest. So in the rest of this lesson, we have some systems of information that we're going to put into equations and solve. So I'm actually going to come up here. I'm going to look at this page, and we can work some examples. So let's talk about this shopping problem, number 5. At a sale, Salazar bought 4 t-shirts and 3 pairs of jeans for $181. At the same store, Jenna bought 1 t-shirt and 2 pairs of jeans for $94. The t-shirts were all the same price, and the jeans were all the same price. So we're going to be saying t-shirts are maybe X and jeans are Y. And you always need to know what your variables actually represent. And then I call this problem the two examples or two situations problem in my mind. I know that I'm going to write a Salazar equation and a Jenna equation. And so I have 2 separate situations that I'm going to bring together that are going to help me solve for 2 variables at the same time. They're going to, since I have an example of one shopper and how much he spent, and the other shopper and how much she spent. I'm going to put those two pieces of information together, and that'll allow me to know how much the t-shirts cost and how much the jeans cost. This is how I would set that up. Salazar is 4x plus 3y equals 181. So I'm going to do 4 times the price of the t-shirts because he bought 4 t-shirts, and 3 times the price of jeans because he bought 3 pairs of jeans. And then I'm going to set up Jenna, and Jenna is going to be 1x plus 2y equals 94. She didn't spend as much money, but she spent the same amount of money on her t-shirts and per t-shirt and the same amount per pair of jeans. So what I'm going to do now is decide how I want to solve my system. So this answer right here would go with A, and now I have to decide how to solve the system. Since I have x plus 2y equals 94, it would be pretty easy to rearrange Jenna's equation to use substitution. I'm going to end up with x equals a negative 2y plus 94. And then I have something that I can plug in and solve. So let's go ahead and do that. I'm going to have 4, and then this is in Salazar's equation. I'm going to plug in negative 2y plus 94 instead of x. So I'm going to keep going. Let's see, plus 3y equals 181. So now I can just solve for y, right? I've gotten rid of the x's. I can solve for y. And if I simplify this, I'll get distributive property negative 8y plus, grab the calculator. There's no shame in using your calculator in algebra class. 94 times 4 is 376. Oh, goodness. 376 plus 3y equals 181. I can simplify. I need to put my negative 8y and my 3y together. So that'd be negative 5y plus 376 equals 181. I'm going to subtract 376 from both sides. 181 minus 376 is going to give me a negative 195. So I have negative 5y equals a negative 195. Finish this up by dividing by negative 5 to get y by itself, which comes out to 39. So I know that the jeans equal $39 each. Okay, that's the price for the jeans. I'm going to plug that 39 back into an equation. It doesn't matter which one I use to figure out how much the t-shirts cost. Jenna's equation is the simplest, so let's just do that. We have x plus 2 times 39, because I'm plugging in the 39 instead of y, equals 94. So let's see, 2 times 39, x plus 78 equals 94. I need to subtract 78 from both sides to get x equals 94 minus 78, which gives me 16. The t-shirts cost $16. So I have found out both of my prices. So systems are good for that sort of thing. Lots of times you'll run into word problems and it'll be like 2 groups of people bought fast food, and this group bought 6 hamburgers and 4 hot dogs, and it cost a total amount of this. But the other group bought 10 hamburgers and 2 hot dogs, and it cost a total of this. You'll get this 2 situations sort of problem in various forms, but what you're identifying is that you have an example and another example, and we're going to make 2 equations, one for each example, and then we're going to be putting those together. Let's look at another problem here. in financial literacy, it says, for a Future Teachers of America fundraiser, Denzel sold food as shown in the table. He sold 11 more subs than pizzas and earned a total of $233. So this is not the two situations word problem. This is a situation where I'm going to need to write two equations based on some information that I'm given. So what I know is that he earned a total of $233. So let's go ahead and make pizza be X and subs be Y, because I'm going to be able to figure out how much pizzas cost. Let's see, we know how much pizzas cost. I want to know how many, not how much they cost, but I want to know how many pizzas and how many subs. So if I do this, I'm going to have one equation that tells me the total number of things, and I'm going to have another equation that tells me the value of that. So the value of that in this one is probably the easier thing to set up. So I'm going to say that 5 times my number of pizzas plus 3 times my number of subs is going to give me a total of $233. Okay, that's the value equation. Now I need to do one more that has something to do with quantity. And lots of times what they do is they tell me that he sold like a total of 100 items, so I would do X plus Y equals 100. But in this case, I have something just slightly trickier. He sold 11 more subs than pizzas. So I have a combination there. If he sold 11 more subs than pizzas, he sold the most subs, right? So I know that the subs is going to equal the pizzas plus 11, because I want to talk about their equal. And I know that I sold more subs than pizzas. So if I want to make the number of pizzas equal to the number of subs, I have to add 11 to it. So now I have a system. Okay, that's the hard work right there. I picked through and I got two completely different pieces of information that I'm going to put together. I want to know where these cross on the graph, and the point where they cross on the graph is actually going to tell me how many pizzas he sold and how many subs he sold. I think I'm going to use substitution for this because I know that y equals 11, x plus 11. So let me get myself a little space here. And I know that I sold 36 subs and 25 pizzas. All right. Sorry for that. I'll try to delete out some of my thinking there. All right. Manuela has a total of 40 DVDs of movies and television shows. Okay. Immediately, I see this coming. X is movies and Y is TV shows, and so X plus Y equals 40. Okay? The number of movies is 4 less than 3 times. Okay, so there's the other thing I have to figure out. 4 less than 3 times. So movies, which is X, equals 3 times the TV shows minus 4. 4 less than, that's this part, 3 times the number of TV shows. All right, and solve a system. So here's my system. And I am probably going to use substitution. Let's x plus y equals 40. And the other one was x equals 3y minus 4. Here's my system. I'm probably going to use substitution and say 3y minus 4, that's instead of this x, plus y equals 40. So I have 3y minus 4. Okay, I didn't need to do anything there. 3y and y gives me 4y. Okay, that's these two guys, minus 4 is 40. we're going to add 4 and get 4y equals 44. Let's divide by 4 and get y equals 11. And then I'm going to plug that back in. I'll get x equals 3 times 11 minus 4. And that's 33 minus 4 is x equals 29. 29 movies and 11 television shows. All right. The Caverns of Sonora have 2 different tours, the Crystal Palace tour and the Horseshoe Lake tour. The total length of both tours is 3.25. Crystal Palace tour is a half mile less than twice the distance of the Horseshoe Lake tour. Determine the length of each tour. So I have 2 situations. I just have to sort them out here. The total length of both tours is 3.2 miles. Oh, so that'll be together. So we have Sonora, Crystal Palace, make that x, and Horseshoe Lake will make that y. And I know then that x plus y equals 3.25. Okay, that's one of my pieces of information. That's the adding up part of it. Then the Crystal Lake tour is half a mile less than twice the distance of the Horseshoe tour. So if Crystal Palace is x, it's going to equal twice the distance of the Horseshoe tour, half a mile less than. Okay, or we could write 0.5. Twice the distance of the Horseshoe Lake tour, half a mile less than twice the distance. Okay, so I have x plus y equals 3.25. X plus y equals 3.25. And then I know that x equals 2y minus x equals 2y minus 0.5. All right, I'm going to use some substitution here. I'm kind of okay with those decimals, so I'm not going to try to cancel them. 2y minus 0.5, that's my x, plus y, okay, there's the x I substituted in for, equals 3.25. There's not anything on the outside of my parentheses, so I can just ignore them. 2y and y makes 3y minus 0.5, 3.25. Let's add that 0.5 to both sides. 3y equals 3.75, and I'm dividing by 3 is 1.25. Y equals 1.25. So I know that y, I have to go back and look, I made a note. Y was Horseshoe Lake. Horseshoe Lake is going to be 1.25, and then we're going to take that x plus y equals 3.25. So I know I'm going to do 3.25 minus 1.25 and know that the Crystal Lake tour is 2 miles long. All right, I'll just set up these other ones. The break-even point is the point at which income equals expenses. Richmont High School is paying this much for the writing and research of their yearbook, plus a printing fee of $25 per book. If they sell the books for $40 each, how many will they have to sell before they break even? Okay, so we want to sell enough books to pay back the amount it cost us to actually print them. We already had to put out $13,200 to write and research the yearbook, and we have to pay $25 per book. So let's say that books are X, and let's say Y is that break-even point. Or maybe we'll just say Y is the amount that we are either owing because we haven't made our money back, or the amount that we're making. So we'll call it our profit. So Y equals 25 times x, this is our cost, 25x plus 13,200. In this case, y is our expenses, okay? And then let's make y also be our income, and let's talk about income. And our income is going to be $40 for each book, 40 times x. So we want to know where our expenses equal our income. At that point, we've broken even. We haven't made money, but we've paid back everything we owed. So we're going to do, we're going to make them equal to each other. And we're going to use substitution for that because y and y equal the same thing. So we're just going to be doing this math. 25x plus 13,200 equals 40x. And then we'll solve for x. And we can also put in y if we want to, although it's just asking how many books we have to sell to break even. Okay, let's talk about Clara and her friends planning a trip to a paintball park. Find the cost of lunch and the cost of the paintball. What would be the cost for 400 paintballs and lunch? Okay, so we have two deals. Go in here, $25 for 500 paintballs or $16 for 200 paintballs, and lunch is included. So we have the two situation thing going here, one situation and two. So we have let's call paintballs x, and let's call the y be lunch. So we have 500 times the cost of the paintballs plus the cost of lunch, and that equals $25 in the first situation. In the second situation, we have 200 paintballs times however much they cost each, plus the cost of lunch, and that's going to equal 16. And so we will be solving this system to figure out what the cost of paintballs is, the cost of lunch. I would just multiply maybe the second one here by -1, and then we can just add these together. That'll cause that to eliminate, and we can carry on from there. All right, so in this lesson, we were talking about picking the best method for solving a system, and we talked through a whole bunch of word problems.